Alright, so back with graphs of exponential functions. With exponential equations, we use these to model things that grow generally by a constant percentage all the time. So whether that's a savings that increases by a compounding rate of interest, whether it's the decay of radioactive elements like we're going to look at here, they're the sorts of things we model with these, and there's a lot of things in nature that use these. What are some of the basics that we need to know? First of all the exponential equations that we're going to look at come from the basic one. If I just had y equals some sort of number to the power of x, remembering that a is greater than 1 here, then anything to the power of 0, if I want to find what that intercept is, that's usually just 1. Anything to the power of 0 is 1. If x equals 1, then I have a to the power of 1 is just a, so that's going to be the point 1a, and it just continues getting steeper as you go to the right. Now, what do we know? If that number increases, if a increases, that base increases, so instead of, if it was 2 to the power of x, it's doubling every time I go up by x. 5 to the power of x would be multiplying by 5, so it would have the same shape but just be a bit steeper. Oh, that got a little bit wonky towards the end, but you get the basic idea. Get out of there, what's that doing there? As the number increases, this thing becomes steeper still and just goes up at a sharper angle like that. That's really all that happens as you change the value. What are the ways we can transform this? The same as always, we could add a number at the end. What happens if I add a number? I shift it up. So if I had y equals a to the x plus k, that just changes the asymptote. And remember, the asymptote is the line that it's close to but never quite touching. Now there are a few exceptions to that, but for our purposes, that's what we're going to think of an asymptote being at the moment. So this would now be the line y equals k. So I've added k, everything's been shifted up by k. So my equation, y equals a to the x plus k, has now just shifted up. So then the intercept there would be k plus 1, and it would work the same way. What are the other ways we can transform these functions? We're going to have a look at that in a final video at the end. But just remember, a negative in front, what does that do? Turns it upside down. If I subtracted a number from x, it's going to shift it left or right. If I add the number, it's to the left. If I subtract the number just from x in brackets, it's going to shift it to the right. The same as it was for circles, same as it was for parabolas, they all work the same. But for these questions, really, you're going to get a few giveaway marks. So let's look at the example here and see how that works. So here I've got my equation. A equals 450, and I believe that says 3 to the power, is that negative t? Would you believe it's a bit small to see on my screen? And that it is indeed negative t. So 3 to the power of negative t. Wow, that's now in really close. Let's zoom back out again. What is the initial amount? So when you're asked for initial amount, and this is a very common question, the initial amount means that t time was 0. So the amount at time 0 equals 450 multiplied by 3. Well, negative 0 is still just 0. Anything to the power of 0 is 1. So the initial amount was 450. They gave us units in grams, so let's keep our units there like good little math students. Part B here. How much material remains after 1 year? What do? Find the value when I sub in 1. A1 equals 450 multiplied by 3 to the negative 1. Now, if you've got your calculator, you can just type that in. Otherwise, the rest of us are going to need to remember our index laws. 3 to the power of negative 1, that's the same as 1 over 3 to the power of 1. Oh, a third of a 450, that's 150. That's not too bad, and that's 150 grams. How much remains after 4 years? B part 2. A of 4 is going to be 450, 3 to the negative 4. That's the same as 450 times 1 over 3 to the power of 4, and of course 3 to the power of 4 is 81. So I'm going to make that, well, that'll be 9 goes into 450 50 times, doesn't it? So it's going to be 50 over 9 grams if you want to have it as a fraction. You could simplify it into whatever you like, but that'll do for me. Determine when the amount will reach 50 grams. Well, it's somewhere between 3 and 4, isn't it? Because after 3, we're going to go 150 divided by 3 again. It's going to be, oh no, there you go. It's going to be even easier. It's going to be 50. Let's see how I got that. I'm going to let A of t equal 50. That's what it's asked me to do. Let it equal 50 grams. So therefore, I've got 50 equals 450 multiplied by 3 to the negative t. Now you could do this on your calculator. Just type in 453 to the negative t minus 50. So if I show you how you could do that on your calculator, 453 to the negative t, take 50, plot that in y1, and then you can solve that to find where it equals 0. We're not going to bother with that because this one's going to be pretty easy. So let's just have a look and see what I'm going to do here. Well, I can divide each side by 450 once I find where my pen is. There it is. So 50 divided by 450, that's 1/9. And that's going to equal 3 to the negative t. 1 over 9 equals 1 over 3 to the power of t. Writing in the answer before I get there. 3 to the power of t still. If those fractions are equal to each other, the denominators will have to be equal there. So 9 is going to be the same as 3 to the power of t. We know 9 is 3 squared. Therefore, t equals 2. Now, back when we did these in class, I showed you the way of actually doing them using logs. You don't need to know logs. We'll do that actually next term. So I didn't mind showing you how to do that. But for what we're doing this term, you're not going to need that. You just need to find the value on your calculator, sketch it, and use a G-solver or solve for the X value or the Y value, whatever it's asking for, and do it that way. That's not too bad. Here they suggest using trial and error, and again, that would be an appropriate way to do it. If I wanted to sketch the graph, though, we should be able to sketch these with confidence. So let's see if we can do that. If I want to sketch the graph here of 450, so A of t equals 450, 3 to the negative t. So remember, when you put a negative just in front of the t value, what happens is it reflects in the y-axis. So our regular shape that looks like that is now going to look like that. And you can see it's going to decrease as I go to the right. That's a little bit wonky. Apologies for that. I think it's the angle I'm holding this tablet at. Let's maybe just get rid of those and try and draw them a little bit more neatly, maybe even cheat and use the axes that they provide us with. How good of them. Now, so 450 times 3 to the t would usually go up like that. This time we're going to be going down. Now, we're not going to be too fussy about the general shape when we sketch these, but let's just have a think. It's going to decrease pretty quickly as I go to the right. So this is A of t. I've labelled that. This would be the amount. This would be time. Label my axes beautifully. That's A of t, and this is A of t equals 450 multiplied by 3 to the negative t. So we just have that general shape. If I wanted to substitute in a point, well, I know a couple of points up here. I know that when t equals 2, the amount was 50 grams. The initial amount was 450, so I can find where there I am. That's 450. And really, I probably could have decreased a bit faster, but we don't really say what our scale is there, so maybe it's 2 over here, and that's the point 2, 50. You don't need to do much more than that. You just need to get the general shape. This one, the asymptote, is still the x-axis. Had I had a bit more skill in drawing, let's just try and draw it one more time, maybe a bit more precisely. It does get a little bit tricky, but let's see. So we're decreasing quickly. Maybe that's a bit better. So it's decreasing to about 1/3 of its height every time I go across by 1. So that'll be 1. That'll be x equals 2 over there. There's 1. And you get the idea. Alright, that should give you an idea for the basics. We will come back and revisit all of our graphs and just look at how they move around in Desmos in the final review for this chapter, but that's how you do the basic questions. You'll find if you go to the exercise and try them, they're going to work pretty easily like that. Alright, good luck. See you in the next one.